So over the last 50 years, conversational interfaces have evolved, right? So when we started, the human beings had to adjust to how the machines, the language that the machines understood. So you had punch cards, memory registers, and then came the state where there was kind of a compromise. So you had pointers, sliders, like a user interface through which you could interact with machines. And then came the conversational interfaces where the machines really understand human beings. And Alexa or the Echo is a great example of a conversational interface. So what are the benefits of a conversational interface? So they're natural. Having conversation is one of the earliest things that people learn. They're on demand. So you having a machine that can talk to you, so you could ask it questions, converse with it at any time. It's on demand. It's accessible. So whether you're driving, whether you're operating machinery, or as some of you saw in the Motorola demo, if you're a police officer and you have your hands full, you can still talk to your computer and access the data that you need to. And they're efficient. The easiest way to put a point across is through a conversation, rather than look at the user interface and click through the entire conversation. So let's look at some of the challenges that our developers face today while building a conversational bot. The first thing is you need language understanding. The second is you need speech recognition. You need security. If you want to deploy these on mobile devices and IoT devices or chat platforms, you need a nice way for you to be able to manage all these channels and deploy to these platforms. That's another challenge that they face. Authentication, scaling these chatbots. If your chatbot takes off, you have maybe 1 million customers that are trying to talk to it. How do you scale? And how do you test it? So, and then finally, the business logic, right? So you can have the conversation, but at the end of it, you need some code that will actually run and fulfill your business logic. And that's why we built Lex. So what is Lex? It's a new service for building conversational interfaces using both voice and text. Here's some of the features of Lex. So the first thing we'd like to talk about is the text and speech language understanding. So you guys would have heard about speech recognition and language understanding. And what we do is put both of them together to give you a text and speech language understanding service. And both these services are the same backend that is powering the Alexa on the Echo devices. So you get a really high quality speech recognition and language understanding. The second feature is easy deployment to chat services. So an issue a lot of developers face is every chat platform has its own way of setting things up, their own authentication mechanism, their own markup. So we simplify all that. I'll talk a little bit more when we get to that section. It's designed for builders. So we have an efficient and intuitive UI on which you can easily configure your conversations. You can test them. And then once you're happy with the way they're functioning, you could build them and then deploy them to whatever platforms you would like. Versioning and alias support. So what we felt was that if you want enterprises to use this, for example, Capital One is using this at a large scale, and maybe they put one of their customer service bots on it, and they launched something, and things didn't go well, and they want to roll it back. So you need things like versioning and alias support for that. Enterprise connectors, you will be able to connect to various enterprise systems through your Lex chatbots. So text and speech language understanding. So like I was saying, it's the same technology that powers Alexa. So speech recognition, what it does is when an audio comes in, it takes the audio and converts that into text. And what language understanding does is takes that text and understands the intent of that text. So let's talk about how you can deploy to various chat services and mobile platforms. So we have one-click deployment to Facebook Messenger as of today, and soon we'll be following up with support for Slack and Twilio. And even today, if you wanted to do a DIY kind of solution, you could still do it. And we have rich formatting support. So I don't know if, how many of you have used Facebook Messenger, but they give you a nice way to kind of put cards in chat so that you could speed up the conversation. For example, if you ask them a question, you could show buttons saying yes and no, and they can just click the button rather than having to type the entire answer. So you have button support. You can also have images, titles for those images. So we provide rich formatting support. And another thing which we're going to be adding is once we add other platforms like Slack and many more in the future, each of these platforms have their own markup, right? So imagine if every browser had its own markup language or HTML, right? It would be a nightmare building web applications. But that's kind of the status today when you look at the different chat platforms. So we simplify that for you. This is, once we launch Slack, you'll see that once you design your buttons, the same thing will be displayed both on Facebook and Slack, and we take care of changing the markup so that they render appropriately on the various platforms. And mobile. So we have deep integration with AWS Mobile Hub. So you guys should check it out. Once you build your bot, you can easily go to Mobile Hub and within a few minutes download a mobile client which can take both text and voice input. Your authentication is already built in. It's connected to Cognito. So we're making it super easy for you, basically give you end-to-end functionality. This is a screenshot of the console. So I'll talk a little bit about the various components here. So at the top, you would see sample utterances. So utterances are ways in which your customers are going to interact with your bot and express their intent. For example, I would like to book a hotel room and so on. And then you have slots right under it, which is the data that your customers are going to give you. So I'll be talking more about each of these components in detail. And then you have, and for slots, you have something called a slot type, and we provide you built-in slot types for things like cities and so on, because we don't want every developer, or every developer doesn't have to prepare an entire list of US cities, right? So we build it once, so it simplifies your development cycles. But if you want custom slot types, you can do them as well. You have prompts, which is questions you ask your customers in order to collect the slots. Then you have what we call a dialogue code hook, which basically helps you do validation and initialization. And I'll have slides to talk about each of these. And then you have a confirmation prompt where you can check whether a customer wants to go ahead with a transaction or not. And then you have intent chaining, and you have fulfillment, where you can specify the Lambda, which actually has all your business logic. And we go into your Lambda account and actually list all the Lambda functions you've built so that you don't have to go to various screens and kind of, it just simplifies things for you. Once you've built it, you can test it on the same screen. And once you're happy, you publish it. So the next feature we will talk about is versioning and alias support. So we have versioning at the slot level, the intent level, and the bot level, right? So these are the three components. Slots are the pieces of data that you need. Intents are the different goals that your bot will help your customers achieve, like booking a ticket, booking a flight ticket, booking a hotel reservation, booking a car, checking status, canceling your tickets, and so on. Those would all be intents. And a bot is a collection of intents. And like I was saying, having versioning helps you have a multi-developer environment where you picked a certain version and started building your bot with that, and then somebody else messed with it, and your bot stopped working, right? But if you're using Lex, that's not going to happen, because once you put a certain version into your bot, it's immutable. Nobody else can change that version. If somebody made changes, they'd have to release a new version. And once you have versions, you can't just have that without aliases, right? Because every time you launch a new version, imagine you have mobile clients and you have like 1 million customers. You don't want to go updating all those clients, right? So they all point to the same resource, which is an alias, and then you just switch out the version that the alias points to as and when you make improvements. So this enables iterative development. And then you could do dev, stage, and productions, right? You could have an alias for production, one for staging, one for dev, and have different versions have those aliases pointing to different versions. And that just simplifies your life, allows you to test various versions and see how they're doing. The next feature we're going to talk about is mobile hub integration. So that's a screenshot of how things look like on the mobile hub. So we have a card for building conversational bots. You just go into mobile hub, click on it. Again, it's deeply integrated. You see all the bots you've already built on Lex. You can choose the one for which you want to build a client, and then hook it up. Cognito comes with it, so you don't have to worry about authentication, and you can quickly download the client and start testing it. Let's talk a little bit about SaaS connectors. So we have connectors to 6 different SaaS systems: Salesforce, Microsoft Dynamics, HubSpot, Zendesk, Marketo, and QuickBooks. And you can connect to all of these through Lambda or from your mobile clients. So this is an architecture where you have a mobile client that is doing the orchestration, right? So let's say you have a salesperson, and he asks your bot, hey, what are my top 5 customers that I should call today? And that goes to Lex. Lex understands the intent and sends it back, saying this is fetch the top 5 leads and the user ID, and then the mobile app uses that information, and through API Gateway and Lambda, it's going to use those connectors to fetch data from Salesforce and return that back to your salesperson. Another architecture is even if we don't have connectors, you can still use API Gateway and AWS Lambda through your VPC to directly connect to your various enterprise systems to fetch data. Let's talk about some use cases. Some of the use cases for bots are informational bots, right? So you could have a bot that gives you news updates, weather information, scores for games, and so on. You have application bots, which are more transactional in nature. Let's say you add a mobile app that you could book tickets with. Now you add a conversational interface to it. So you can do booking, tickets booking, ordering food, managing bank accounts. You want to check what's your balance, how much you spent on groceries, and so on. You could do all that using bots. Enterprise productivity bots. So like I was saying, your salesperson can just talk to the bot and ask it questions. Your marketing person can say, what was my conversion like? What was my traffic like? And so on. It just improves the productivity of your enterprise workforce. And then IoT. So later today, you're going to see a demo from one of our customers. So Lex works great with IoT devices as well. Some of the benefits of Lex. So it's easy to use because it provides you an end-to-end integrated functionality, right from your mobile client to your conversational interface to your business logic, and all the ancillary services like DynamoDB, CloudWatch, Cognito, and so on. High quality text and speech language understanding. which is powered by the same technology that's powering the Echo device and Alexa. Seamlessly deploy and scale. Again, it's a serverless architecture, both Lex as well as Lambda, so you just don't have to worry about setting up your servers, your load balancers, and worrying about getting spikes in demand and so on. It just scales. And you can deploy to all these multiple platforms. Built-in integration with the AWS platform, have access to all the rich functionality on the AWS platform, and it's cost-effective. So this is the structure of a bot. So let's look at the various components that makes up a bot. So we touched upon it when I showed you the user interface. So there is intents. So essentially, an intent is a goal that your customer is trying to achieve. For example, booking a hotel, booking a car, checking the status, canceling a booking, and so on. And a bot is nothing but a collection of various intents. Utterances. Utterances are the spoken or type phrases that invoke your intent. So there will be things like, I'd like to book a hotel, please make a reservation, and so on. Slots. Slots are the data that you need in order to fulfill that intent. So if you want to book a hotel, you need to know when, how many people, what kind of room, which city, and so on. And what date. And then fulfillment, which is you actually need to go into the hotel reservation system and put in that booking. So that's what we mean by fulfillment. So let's talk about each of these. So I was saying utterances. So these are some of the examples of utterances. I'd like to book a hotel. I want to make hotel reservations. So what we do with Lex is provide sample utterances. So you give Lex maybe 10 to 20 sample utterances, and it gets sent to the Alexa backend, where we build an intent model and a slot model, which actually is able to understand many more dozens of related utterances, right, based on the sample set that you provided. And that's basically the value that natural language brings compared to just bots that are that you build without the natural language capabilities, right? With those, you have to look for that exact string, and your customer has to type that exact thing. But with natural language capabilities, they can say things in a conversational manner, and based on the utterances you provided, your language model is going to pick up what your customers say. So here's some example of slots. So destination, check-in date, check-out date, these would all be slots. Slot elicitation. So this is one of the important features that Lex provides, and we spent a lot of time designing this to make it really easy for developers to enable their bots to have a conversation, right? And it's especially challenging because you just can't predict how your customers are going to interact with your bot, right? You can't predict what they're going to say. So for example, if you ask them, where do you want to fly to, they could say, I want to fly to New York City on the 30th of November, right? So you ask them for one, they give you two, right? So that's, we call it overfilling, right? So you need to be able to handle situations like that, and that's what Lex does. So it's able to, at runtime, figure out what is the data that you need from your customer based on what they've said so far, and adapt to the situation and ask the appropriate prompt. And that's where we spend a lot of time designing this particular component. So this is a happy path where you said, I'd like to book a hotel, and it prompts you, your bot says, sure, what city do you want to book to? You said New York City, and then what day do you want to check in, and you gave it a date. But even if you had said New York City on the November 30th, it would fill the slot, and then it would not ask you what day do you want to check in, because it knows you already gave it that data. Let's talk about fulfillment. So fulfillment is basically the business logic that needs to run in order to achieve fulfill the customer's intent. And we have inbuilt integration with Lambda, like I was showing you on the console. It's just a drop-down. Once you've written your Lambda function, it's visible in your Lex console. You just pick the appropriate Lambda function, and it all works. And we give you seamless interoperability between your Lambda and your Lex runtime. Right? So you can do things like session management, where your Lambda can set certain variables in the session, and you can access that from your Lex runtime. So, for example, the user's payment details or their current location. So your Lambda can really go fetch all the data, set it in the session, and your Lex runtime can, your name, your user ID, and so on. So it could personalize the experience by using all the data that your Lambda is pulling and setting in the session. And we understand that different customers have different needs. So maybe you have an application already, and you have all the business logic running on your mobile application. So you just need a natural language interface to have that conversation and give you that data. So we have an option for you to return all the data back to the client as well, and then the client's responsible for booking the ticket and so on, and messaging that to your customer. Here's the complete flow, right? So your customer said, book a hotel in NYC. So ASR, what does it do? It takes your audio input, splits that into its various components, which is book a hotel in NYC. And then that text gets sent to your natural language understanding system, where you already built the model with your utterances and slots and all that. So you have an intent and slot model. So it's able to understand that the intent is hotel booking, and the city they want to fly to is New York City. So it already fills those slots for you. And then it will go and ask you for your date, right? And then it'll ask you for check-in date, and then a checkout date. And then you can add things like how many people and so on. And do you have any preferences? So this is just a simple example, but you could just make it as sophisticated as you'd like. And then once you have all the data, you can say, can I go ahead and make your booking? And that is another feature that Lex provides, which is called a confirmation prompt, right? Because if you want to have a transactional bot and you want to ask people to book tickets or buy stuff which is worth a few $100s, you just don't want to go ahead and place an order just because you have their credit card details. You want to ask them one last time, just like you do on the Amazon website, do you confirm that you want to buy this? And they can say yes or no, and we're able to handle both use cases. And you'll see on the console, you can specify the messaging in either case. If they say no, you could gracefully exit saying, OK, your ticket has not been booked. Again, that's really important, because imagine it asks you, do you want to book your tickets? And you say no, and it just goes quiet on you, right? Then you're worried, oh my God, did it book my tickets? What's going on? Did my credit card get charged? So having that kind of flexibility in messaging is really important. And then it hands it off. Once you confirm, it hands it off to Lambda. It does its thing. It goes into the hotel reservation system, books your tickets, and then returns successfully. And then you can message to your customer, your hotel is booked for November 30th. And then, again, it's easily integrated with Poly. You don't have to do any work for it. It's pre-built integration. When you create your bot, you can just pick the voice on Amazon Poly that you'd like to use, and it all works. And then that converts into voice and goes to your customer. But if you want to do text, then you could use a different API. We have APIs for runtime for both text as well as voice. So you just use the text API, and you'll get a text output. And you would get those rich cards as well that you would display on Facebook or any other chat service. This is the save, build, publish workflow. So when you save, you just save the state of your bot, and developers like to keep saving their work so that they don't lose it. So we don't create versions every time you save. It just saves the state, the current state. When you click on build, that's when we actually create the model for you. We go into the Alexa backend, and we create a natural language model. And that's what your bot is going to use in order to interact with your customers. And build is when we also create versions for your intents and slots. And once a version is created, it can be changed. You can always create another version and include it in your bot, but a version that's already created and released cannot be touched. And then you test it. You have the chat interface right on the console, which you could use to test your bot, have the conversation, see how it's functioning, and then you publish it, which is when you create a new version of your bot, and it gets an alias as well. Let's talk about monitoring. So, with anything that you launch, you want to be able to see how it's doing and improve it over time. This is an area where we're going to keep launching a lot more functionality, but for preview, we're going to have these three, which is a missed utterance count. Right? What do we mean by missed utterance count? So when customers are talking to your bot, they're going to say things in whichever way they want to say it. And then maybe your sample utterances were too few, right? And you didn't cover those different ways in which people communicate. That's where you would have a missed utterance, where it doesn't hit any of your intent. Your NLU model says, I'm sorry, I didn't understand what you're saying. Would you like to book a ticket? And that would count as a missed utterance. And then the latency, which is how long each request is taking to return once you made a request to the bot. And then the traffic, which bots are getting the most traffic, which are most popular, and so on. Here's some customer testimonials. So in Capital One, they're really excited about Lex, and they recently launched a skill on Alexa, and they want to continue building conversational interfaces and actually expand the reach of their conversational interfaces to other platforms like Facebook and their own mobile app and so on. So they're excited about using Lex. HubSpot, which is another customer, that they have a bot that they've just hooked up based on like I was showing you in that slide, pulling all the different technologies together. But they are very excited about using Lex to have one easy way to just build their growth bot, which helps marketeers ask questions like what's my traffic like, what's my conversion like, and so on. This is the pricing. So we're going to charge 75 cents per 1,000 text input requests and $4 for every 1,000 speech input requests. And then we'll have a free tier of 10,000 text input requests per month and 5,000 speech input requests per month. And this is the kind of architecture. So you have, on the left side, you have the ways in which your customers are going to interact, and developers are going to interact with Lex. So the console and APIs let developers at build time set up their intent, slots, prompts, utterances on Lex. And then you can test it and deploy it. And then at runtime, we provide SDKs through which your mobile clients, IoT clients, chat services could send in either speech or text input and interact with their bot. And once that input comes in, you kind of work with the Alexa speech recognition and language understanding components, use Cognito for authentication and for logging and metrics, CloudTrail and CloudWatch, and then Lambda for both customizing your dialogue as well as fulfilling your business logic. And then once it's all done, you stream the output back through Poly if you want voice, or you could just send the text back to your customer. So with that said, I'd like to hand it off to one of our customers here who's built a really cool demo for you And that's the most exciting part of building these services, when you actually see it in the real world and people are actually using your service. So I'd like to invite on stage Tom Soderstrom from NASA JPL. Give him a big hand.
Thank you. Thank you very much. And you're going to see this cute little guy or girl, your choice, drive in a minute. But before we do that, let me just talk about what we do at JPL and NASA. We look for answers to the big questions. And this is a picture from space. So that's where we spend most of our time. Now, hopefully, by the end of this, you'll figure out what on earth does that have to do with a toy. It has everything to do with a toy. We're looking for questions like, how did the universe form? Where is it headed? How do we protect Mother Earth? How can we predict hurricanes, et cetera? How do we divert an asteroid? Would anybody care about that? I hope so. Are we alone? Is there life out there? And can we find Earth 2.0? If we needed to migrate humanity, would we have a place to go? These are things we're looking at. And of course, besides from Matt Damon, is there other life on Mars? So if you look at this is the first selfie from another planet. Just like any teenager would, the robot Curiosity stuck out its giant robot arm and took a selfie. So we could make sure it's healthy. Now, that kind of looks like our cute little Robi here that you'll see in a second. That's the point. The point is that today's toy is tomorrow's tool, but we don't know which one. So what we created is this little toy ambassador, Robi. It's a remotely controlled outreach rover, hence named Robi. OK, so naming may not be our strength. It travels to universities, to museums, to schools, and even been to the White House. The idea here is to inspire the next generation of explorers so that to answer these big questions, I've seen an evolution of pace. It's much, much, much faster than we ever thought before to get to the answers to these big questions that affect all of humanity. And as you'll see here, when we first did this, it was Alexa voice services, and Mick, who's going to demonstrate it, said, I'm going to switch to Lex. And I said, what? Because this was last week. Seriously? So he did. And we'll see if it works. But come on up, Mick, and let's give Rovi a run for across the stage. When you look at this, it's an outreach ambassador to get people interested in space and science and building robots. It's all off-the-shelf components. It is Raspberries, Arduinos. It is open-source software, 3D printed parts for just a few cents on any 3D printer. And it is AWS. It's got Lambda IoT. It's got Lex, and it's got Greengrass. But we're going to focus on Lex. The other piece I wanted to look at, I look at the future a lot. And one of the most important technologies that are happening, and most important capabilities, and the most difficult one, is conversation as a platform. We want to be able to talk to the room. So you want to be able to talk to the car. You overlay all this AI that AWS has announced, and you got an amazing future. So why don't you talk us through the rover, Mick?
Sure thing. Thanks, Tom. Thanks. So thanks to Tom, and thanks for Vikram, and thanks to all of you for showing up. It's really what makes this all worth it. So before Lex existed and before AVS existed, both of these are fairly new, we drove Rovi with this thing, this anarchic type of thing that you have to touch and all of that.
For us older people, it's a joystick.
It's a joystick, yeah. So for Rovi, once AVS came out and once Lex came out, somebody saw the work that we were doing with the NASA Mars Alexa skill, which Tom announced last night. And so she saw some of the work that we were doing there, and she said, I have an outreach rover. It would be fantastic if the outreach rover could answer kids' questions about Mars, right? Like, how great of a feel-good story is that to be able to say? And I said, OK, maybe we can build that. So this is what we have today. This is Rovi. It's powered a little bit by AWS Greengrass. First off, show of hands, who was just in the IoT State of the Union or saw it? OK, so I can't use the same jokes. Too bad. I only have two anyways. So this is powered a little bit with Lex and a little bit with AWS Greengrass. I'll show you the Lex parts now. So the first thing that we programmed it to do is respond to questions about Mars. Rovi, how big is Mars?
Mars is about half the size of Earth. Its land area is about that of all of Earth's continents put together.
Rovi,
If you want,
what is the radius of Mars?
the average radius, distance from its center to its surface, of Mars is 2,107 miles, 3,390 kilometers.
So that's just using some of the basic kind of the utterances and then the intent that Vikram was talking about before. Even with something as simple as that, we can't predict every single word in a question that anyone could ever ask this thing, right? We have a database of maybe 1,000 answers that people kind of ask different flavors of questions for. We need to be able to find the answer that's relevant without knowing every single word and letter of the, expecting that and pulling that out of the audio. It's just impossible. You wouldn't be able to do this and give it to a kid and have it work. But because of the way that Alexa's brain works and that Lex's brain works, I can specify a few sample utterances, which is what Vikram was talking about, and say, these are the types of questions that people are probably going to ask. They're going to say Mars a lot. They might say radius, all those types of things. And then using the natural language engine that people way smarter than I have come up with on this thing, it kind of fits what it thought I said to one of the questions or the intents and the utterances that I've given it before. So that is one utterance, is me asking it a Mars question. Another utterance is, and this will hit a different portion of the Lambda function when it gets fulfilled at the end that Vikram was talking about. Another portion is the actual driving. We'll just make sure she doesn't drive off the stage there. Rovi, drive forwards.
vroom vroom.
Rovi, turn left. Rovi. Rovi, turn left. She didn't hear me the first 2 times I asked.
Vroom vroom.
Rovi, stop driving.
Stopped.
And then in addition to the simple, drive left, drive right, stop, all of that, there's also a following mode. Those of you who saw it would have seen, well, I can show it here too. It's another intent. So we have a 3D camera on the front. Rovi. Rovi. Follow me.
Following.
So if I get too close to it, she can tell that I didn't shower this morning. So the way that this is working is there's the 3D sensor there is mapping out the space in front of Rovi and seeing where I am, sending those messages up to AWS IoT, the IoT service, and then the wheels are subscribing to those IoT messages as well. Rovi. Rovi. Stop following. So that's a little bit about how Rovi works, the driving and the speaking as well.
Stopped.
Thank you. So that was the demo. This is the big scary architecture diagram for how this works. Lex is the nice blue diagram, the little icon over on the right, one of the things that resides in the AWS cloud. So everything that we built here locally on Rovi, it kind of starts from the voice user, that's me, component, right? So I ask a question. There's a little script on here that is using a hot word detector to figure out whether or not I've said Rovi. That all happens locally. We're using Snowboy if you're interested in it. It does a very good job of local hot word detection, but it's like 1 or 2 words tops. That's the best it can do. And so once it's heard that I've said the word Rovi, then it wakes up and it starts listening to the audio. This is going to be the meat of it. What do I do? So it records that audio. When I've stopped talking, it takes that snippet and ships it off into the cloud to Amazon Lex. Now, the entire time that that's happening, so you could see the LEDs when I say Rovi, they turn a different color. When she's thinking, it turns a different color. When she's doing the thing, it turns a different color. That's being published directly from the body to AWS IoT, which is then picked up by the head. So that's a little bit separate from Amazon Lex. But then, for example, the ones that are driving, the drive forwards, turn left, turn right, Amazon Lex, under the fulfillment, after it figures out the response, vroom, vroom, it's actually going to call a Lambda function which will spit out to IoT the drive commands. those are picked up then by the listener, which actually turns the wheels. So that's kind of the best elevator pitch I can give about the way that Rovi works with Lex. Some of the features that Vikram mentioned that were surprisingly important to us, one of them especially was being able to test the bot in a chat window immediately after you build it. It sounds like a minimal thing, and I would have thought that too, but after testing this, so you can imagine this, I'll give you a secret, this used to be built on AWS before Lex was announced. It took a little bit longer, and you can imagine because it was built on AWS, it's a different use case that they had in mind with AWS, right? They wanted the whole thing to be Alexa. You could say, Alexa, to wake it up. You could ask it, what's the weather on Earth? What's, my travel itinerary, this kind of thing, what's on my calendar? This is not really the use case that we had in mind here. So the way that we hacked around that was originally, I actually had audio on the rover of me saying, open NASA Mars, or open Rovi. And then I was prepending that onto whatever audio we were sending to AWS so that it would always come back with one skill. So we were only ever using one skill. The bot is a much simpler, much more streamlined way to do this. And it was all extremely simple to forklift over. As Tom mentioned, it took like 2 developer days. And that's me, and I'm not that good of a developer. And it took, it took no effort, relatively speaking. The Lambda function is mostly the same. It's going to require 3 or 4 lines of code to change is all. All the logic is the same in the back end. All of the normal kind of the sample utterances, the files that you've been building up and putting into your Alexa skills, they can mostly just be copy pasted right into Amazon Lex, and it's going to work for you just the same way. So it's been really fantastic for that. So why we care about this at JPL? This is a little bit more than just Rovi. This is not the end-all be-all of Lex, right? So one of the things that we dream about at JPL is a more natural interface to any robot. Forget about robots, anything, any whatever, right? So we at JPL do some work with mining robots as well and with rescue robots. And so we've designed entire robots, RoboSimian, if you've seen the videos, that are supposed to look friendlier, and they lift things up, go to earthquake, disaster recovery areas and actually try and move hardware to, and you can imagine if a robot comes into you, you're trapped under some sort of collapsed building, whatever it is, and they lift this thing up, what's the first thing you're going to do? You're going to say something to it, for sure, right? And so this would be an amazing way to start playing with that. Integration, even in a less crazy scale, would be workplace equipment. So walking in to a museum exhibit, and so for instance, we want the capability of Alexa and of voice on many of these exhibits that we have. So I want to be able to walk up to a model, and if I have a question, I want to be able to ask the model for the question, right? So it's a Mars rover. Well, how much does this actually weigh? Right, there's the answer. And so we could start building that in with Lex. And then information kiosks, and even to control devices around labs. So can we build something like this to control a bigger device that we actually use to build real spacecraft that'll be launched on orbit or to other planets? And then the last one that's also very interesting to me especially is kind of building in these really powerful chat ops capabilities. So I don't actually really want to have to do any work. If I have a question, I want to just be able to type it or say it and get the answer back. And this is going to give us a lot of those capabilities, right? Triggering workflows, starting queries or whatever it is, all through either text or voice. And I think that's really the true power of Lex, and I'm very excited about it.
So I think just a couple of other use cases that we think are important. Having the local execution and having the ability to tie into the brain of the internet, and now the AI, is a really big deal. Imagine this going into a mine, finding out what's going on, coming back out, doing some analysis, and then going back in again with much more information. Or we have rovers that go under the ice cap and investigate what's going on. All of those things are amazing. They take a lot of specialized programming today. You have to have the experts that know how to do this. Then they take the data back, come back from Antarctica, and then upload it. It's a completely different world now. They could do the development there. They could change things. And it's the same coding. So that's one. The other one is, that just actually came to me as I was listening to you, which is the help desk. So JPL, we work in space. We're also an enterprise. We've got about 5,000 people. And so we have help desks and things like that. Being able to do a chat with a help desk that then tells you what to do beats the heck out of calling somebody and sitting on hold. And it helps everybody. So there's a lot of interesting use cases here, and the speed of development is really what's so exciting. even when you scare me half to death with the speed. So I think that's, with JPL and NASA, we're very excited about this, all of this new technology, and especially the AI. If you can imagine for a second a data lake where all the data sits, all the cold source data, and then you imagine that you have devices. All of these devices, whether you type, you click, you blink, and there's APIs that tie into all that. Having a conversational API that ties across all of that is going to be really the future. So conversation as a platform is what we're looking for, and we're almost there, so thank you. So thank you very much.
Thank you, Tom and Mick. All right, so let me get back to All right, so the question I'm sure most of you have is, how do you get started using Lex? Go to aws.amazon.com/Lex, and you can put in a request to get whitelisted, and we'll keep slowly start sending out whitelisting invitations, and then you get access to Lex. We're going to be in preview, so please be patient with us. If it takes a little bit of time for you to get your invite, but that's the URL. And I'm just going to open it up to questions.